Welcome to The Explainer. Today, we're stepping right into a really profound intellectual mystery, one that's sitting perfectly on the edge of tomorrow's tech. We're looking at the future of artificial intelligence, but, not through the usual lens of faster chips or massive data centers. Instead, we're zeroing in on a wild paradox quietly forming inside the very architecture of machine learning. It's basically a mystery about what happens when the seemingly limitless well of human knowledge runs dry and the machines have literally nowhere left to look but at themselves. So what actually happens when AI stops learning from humans and starts learning from other AI? I mean, think about it. Right now, the internet is becoming increasingly flooded with AI-generated text, images, code, the whole shebang. Because these AI models require massive amounts of scraped web data to train their next versions, it is absolutely inevitable that tomorrow's models are going to feed on the output of today's models. But what happens when artificial intelligence becomes both the student and the teacher? Does it get smarter, or does something else happen entirely?
Okay, let's dive into Section 1, the probabilistic machine.
To really unravel this mystery, we first have to understand the hidden mechanics of how large language models actually process what they consume. And it helps to remind ourselves of a massive fundamental shift. For decades, we lived in a deterministic digital world. You query a database, you get a fixed, predictable answer. Simple, right? But as researchers at TechRadar point out, modern AI models are completely different. They are probabilistic. They aren't looking up facts, they're calculating the statistical probability of the next most likely word. So if you expect guaranteed truths and total 100% accuracy from a probabilistic system, you're kind of expecting the wrong thing.
Which brings us to a super controversial, but absolutely crucial point. Hallucinations are a feature, not a bug. Crazy, right? But why? Well, because during their post-training reinforcement phase, these models are rewarded for providing an answer. They're practically never penalized for just saying, hey, I don't know. It's exactly like a student taking a multiple-choice test. The system is designed to take a highly educated guess rather than leave the page blank. Errors are just an inherent, inescapable part of their underlying design.
So what happens when you feed those probabilistic errors right back into the system? Let's move to Section 2, the broken telephone.
Now, what's really interesting about this is how it triggers a degenerative process known as model collapse. A major study published in the journal Nature found that when AI recursively trains on its own data, it literally forgets the true underlying data distribution over successive generations. It's exactly like that childhood game of broken telephone, where a whispered message gets totally distorted as it passes from ear to ear. Information passing from AI to AI degrades in the exact same way. The model slowly but surely forgets the true reality of the original human data it started with.
The Nature study actually mapped out 3 distinct mathematical mechanisms that cause this collapse. First up is statistical approximation. Basically, because AI only samples a finite amount of data, information naturally gets lost at every single step. Second is functional expressivity, meaning neural networks have limited capacity, so they can introduce probabilities where none actually exist or ignore real ones altogether. And third, functional approximation, which boils down to biases within the learning procedure itself. With every generation, these 3 errors cascade and compound.
To show you just how extreme this compounding error gets, researchers ran an experiment tracking a text over 9 generations of AI training. Now, at generation 0, the text was a purely factual academic passage about 14th century church architecture. By generation 1, it had drifted into discussing Pope Innocent III, and by generation 9, the text had completely, totally decayed into gibberish about white, blue, red, and yellow-tailed jackrabbits. No joke. The AI completely hallucinated a bizarre new reality out of thin air.
But here is the truly chilling reality of what happens before that total jackrabbit collapse actually occurs. The tails of the original content distribution disappear first. Now, in statistics, the tails represent your low probability events. But in human terms, that means rare data, marginalized viewpoints, and complex human nuances. They are the very first things to be erased. The AI just starts overrepresenting the most common, middle-of-the-road information. For us, this means future AI could become this bland, uniform echo chamber that's totally incapable of producing truly creative or diverse ideas. But wait, couldn't we just, program the AI to double-check its own work? Let's look at Section 3, the rubber stamp. Recent research from Archive looked specifically at AI writing and reviewing software code to see if we could stop this decay. They tested 3 different review methods on coding LLMs. First, they tried no review, which, as expected, led to the fastest model collapse. Next, they tried human gate, using objective compilation checks.
basically asking, does the code actually run? Surprisingly, this slowed the collapse, but it still couldn't stop it. Finally, they tried AI self-gate, where the AI uses its own metrics to review its own generated code. And the results here were absolutely fascinating.
And this brilliantly illustrates the core problem. The AI self-gating system eventually enters what researchers call a rubber stamp regime. It's wild. Its internal acceptance scores actually go up, meaning it becomes incredibly confident that the code it's producing is absolutely fantastic, all while the actual objective correctness of the code plummets. An isolated AI falls into this bizarre self-confirming loop, confidently accepting completely broken information while genuinely believing it's improving.
Which brings us to our final chapter, Section 4, Preserving Original Knowledge.
If unchecked, recursive training turns history into jackrabbits and high-scoring but totally broken code, how do we prevent our vast digital libraries from fading into endless shelves of identical machine-generated books? Well, the Nature study actually tested a solution. They found that if you preserve a random 10%, literally just 10% of the original human training data, and reintroduce it across the new training epochs, the models can successfully learn with only minor performance degradation.
So, the absolutely crucial point you should take away from all these sources today is this: AI cannot survive in an echo chamber. For sure. It requires exogenous verification, meaning checks from outside the AI system itself, and it needs genuine human grounding. Data collected from actual genuine human interactions isn't just a nice-to-have anymore. In a future flooded with LLM-generated content, untainted, pure human data is going to become our single most valuable technological resource.
Which leaves us with this final thought to really chew on. We spend so much time worrying about AI replacing human intelligence. But as we've seen in this explainer, without a continuous injection of human nuance, diversity, and reality, artificial intelligence literally collapses in on itself. If AI becomes both the student and the teacher, humanity's original knowledge doesn't become obsolete, it becomes the only thing keeping the machines sane. Thank you so much for learning with me today, and keep asking the big questions.